Welcome to Professor Russell Esposito's channel on information security. This video is just one of many video modules that are part of Professor Esposito's course on the subject. Video modules for his entire information security course are located on this channel. So remember to hit the like button as well as subscribe if you enjoy the video. Thank you for watching.
Application data and host security. In this module, we'll take a look at development, industry guidance regarding secure coding, hardening devices, hardening really application software and operating systems, looking at some other related items like data loss prevention. We'll also look at some different technologies, VMware, virtualization, using VMware, storage area networks, various kinds of RAID technology, which is a disk technology to prevent loss of data. And it's important to do, log reviews and security and some other items we'll cover in this particular module. DevOps versus DevSec Ops. So this is development operations versus development security and operations. So the left-hand side of the slide shows sort of the traditional development. Top circle there on the left, application delivery. There's obviously testing before delivery. And then operations, it goes live in production. And security was sort of an afterthought. Security looking at an application once a year, or maybe companies would look at applications a few times a year, do a penetration test once a year. And we're really moving to a model of development, security, and operations, where they work together. Development, and you have working the top blue bubble on the right to the bottom security bubble, sort of working together. And then so that's there's security looking at the development as it's taking place during the development cycles. And then there's application delivery and then operations, the green and the pinkish red. So the concept here is to develop security as part of that whole environment of developing systems, implementing systems, integrating systems, and moving them to operations, live production. The security can't be an afterthought, right? It's got to be, should be part of the whole process. So this is a little more detail on DevSecure Ops, development, security, and operations, DevSec Ops. And this is sort of security's view of how this would work. And again, sort of high level, right? We start at analyzing, what are we planning? What are we coding? What sort of hardware is involved? What might be some risks? What might be some vulnerabilities that would be potential, and then coding is to the left, and then secure, implement a defense strategy. What would happen? How do you monitor this? How do you monitor this? This application, build it, and then some testing, sort of continuous testing, verify, automate security testing, and we'll look at some tools for that later on how you can actually sort of test your code for security. And then sort of to the right on the orange, there's release, deploy, operate, and monitor. And during that production life cycle on the right-hand side in operations, with that orange-ish color, defend, detect attacks and prevent exploitations. How do you defend it? So this is sort of a review of how security looks at DevSec Ops. So these are a few sources that provide industry guidance for secure coding, safe programming. There are lots of different sites, obviously, for all sorts of security, but these focus specifically on coding. So Carnegie Mellon has a site that offers a number of different topics in this regarding secure coding, including what they think the current threats are and different training and educational connections. OWASP is a nonprofit organization, stands for Open Web Application Security Project, and they have conferences and chapters you could join, local chapters in different parts of the country and different parts of the world, actually, to look at web applications specifically and how best to code them. Now we'll learn later on in the chapter that this is a pretty complicated subject and it's hard to do this on your own. And unless you're a security company, you're designing security software, or virus protection or something like that, or you're large enough like a Microsoft that really has to engage in doing this secure coding on your own. What most companies will do to support their IT security is partner with what's called Managed Security Service Providers, MSSPs. We'll learn more about that later on, but I just want you to understand that people aren't, for the most part, trying to do secure coding on their own. There are lots of tools as well that you can purchase, and these are just some free sources that that people look at that are well known. So let's talk about some secure coding concepts and standards. So hackers, bad actors, they try to fuzz input fields, and what that means is they'll look at a search field on a website, a password site where you put your ID and password, any place where you could type in information. On social media, there may be areas where you put in comments and notes and things. Any place that you could type information on an application, and they'll try to fuzz the application. By fuzzing, I mean they'll try to put junk more or less into that application. That's one of the things. Or they could try to put code in there, like a script, a JavaScript, some kind of program that would create either copy information, steal information, or bring your system down. So there are two things in this fuzzing attack. One is just to crash your system, and certain things happen that help hackers when they crash it, or they could try to inject code. So let's look at the first, and by the way, OWASP, as you see in the first bullet here, has a fuzzing tool, a free tool you can use to help fuzz your input fields. You do the fuzzing yourself, so you can find out what the vulnerabilities are. So really what you need to do is cleanse the input. The last sentence here on the first bullet, cleanse actual input to the applications. You have to check what's coming in. You have to cleanse it. You have to make sure there aren't scripts being input in there. You have to make sure there isn't something that's excessively large that will cause a memory problem, a large input where they'll put in thousands and tens of thousands of characters to try to crash your system. So you have to go through some edits to ensure that the data being put in these input fields doesn't include programs or scripts, doesn't include excessive data that might crash your system that your application won't know how to handle. So this unexpected input, second bullet, creates errors and vulnerabilities. It can cause your system to crash. When it crashes, it could display useful information that hackers like. Something about what kind of operating system you have, what version you're on, what kind of web service this may be, web server it may be, whose is it, what's the product. Is it Microsoft's or someone else's? And they can also access potentially files and databases when your system crashes. Could allow a hacker to transverse the file system and move around. So when the system crashes and unexpected things happen, it creates vulnerabilities. So you don't want your system to crash because somebody fuzzed, put a lot of junk or code into your input fields. It could provide elevated access. You can potentially have a hacker get in and move around the system because the access is now being bypassed somehow because of the crash of the system. And the other thing is, you have to do code for error handling. All of these errors have to be prevented so that the system responds in a way that you want it to respond and not crash. So prevent these bad system responses as much as possible by coding error handling techniques. So these kinds of errors don't happen. It doesn't crash. This unexpected input won't crash your system. One of the things that hackers like to do, we mentioned briefly earlier, is put scripts or code or programs into these fields. So an SQL code injection would include some characters like 1 = 1 and the equals within quotes also. And those kinds of inputs need to be blocked, cleansed, not allowed to pass through your system. And what an SQL code injection does, it tries to dump your database and read all of your data. And we'll look at SQL injections and some variations of that when we look at the malware and vulnerabilities chapter. So coding takes a lot of time, but sometimes you need a balance between application delivery and code quality. So at some point you have to you test. At some point you have to deliver your application, right? So there's always this natural healthy tension between the application developers who want to put their application in production and the security and the testing folks who want a perfect system. And it's a healthy tension, it's a healthy balance, but you can't test forever. At some point you have to feel like you're confident enough that the system's protected enough that you need to put it into production. So you have to have strong quality assurance, QA, that tests your applications. And on the bottom of the screen here I put four environments that are very typical. A development environment where folks do their coding, a testing environment where the same program is tested in a larger scale. So in development, they'll do like unit testing. They'll just test the function they're working on. In the test system, they'll test they'll test their code with everyone else's code, the team that's working on this application. They'll test the entire application, a large scale test of the entire system. And then you move that code to quality assurance, where the business partners, the users, the folks who are going to use the system, whether it's customers that you have in a group, or whether it's mostly employees, to try to test the system, try to break it, see what happens if they do unexpected things to it, look at if the functions are complete, if they're handling all the use cases, all the possibilities of how the system would be used. And then when they finish testing, assuming that the test phase and the QA phase do not force the product to go back to development, which it ordinarily does. You usually go from test back to development a few times, and then you get through test to QA, and then it might go back to development a few times, and then it'll finally go through test, QA, and into live production. So that's kind of the whole life cycle, is what they call it, of application development. The life cycle of application development has to have some rigorous testing, obviously. Okay, let's talk a little bit about validation and keeping your input fields cleansed and preventing hackers from putting in scripts, programs, or just a lot of junk like thousands of records to crash your system. So it's called validation testing, or validation. So on the server, you're going to have a server to client input validation, both on the browser and on the server. The server side is more secure, server side validation. It can't be bypassed by the client validation, by anybody's client, by any change to it. So that it's important. You have to have the input fields protected, so that you don't have this virus. I don't want to say a virus, but potentially it's kind of a virus or a script or malware or some kind of fuzzing attack on your input fields, whether it's a search field, a comment field, an ID or password field. They'll all have to be protected. On the browser, on the client side, you also need to put those controls in, just in case something happens to the server side validation. Let's say some code is changed, and inadvertently the validation is shut off or disabled or damaged. So you don't want to have no protection. You want to have some protection. So the client also has to do validation. It's like having a belt and suspenders, right? In the IT world, you need both. So you also put the validation testing on the client side, but a hacker could disable JavaScript. They can intercept an HTTP post and modify it before it gets sent to the server. So you want both. You want it on both the protections on both sides. It's also critically important to have it on the server side, because a hacker can develop, and I'm looking at the middle of the slide of that black box with the access granted. Hackers develop their own fake client-side applications, whether it's a browser or some other kind of client application. They can create their own product. They look at your code. They try to figure out how to enter your server. They create their own fake browser code. And it doesn't have to look pretty. It's not like they're trying to get people to use it, like in different kinds of attacks where they try to capture people's passwords and things. It's for their own purpose. It could be ugly looking. It doesn't have to look anything like your browser or your code in the browser. So they create something that bypasses all these edits, and they can put their scripts in. They can run programs, input programs into your server to try to crash your server with fuzzing attempts. So you do need to have, obviously the most important place is input validation on the server side. But again, have it in both places in case there's something fails on the server side with respect to these protections. If you're not aware, you've probably seen emails or text messages from your IT department or some products you might use from their customer service department about monthly maintenance or weekly maintenance. So IT needs to deploy patches to applications and operating systems, new releases, hot patches if they're sort of urgent repairs to cover a vulnerability that some hackers discovered. So they need to continually do this patch management. It's a lot of work. It has to happen on applications and on the operating systems, the OS. Microsoft has something called WSUS, Windows Server Update Services. and it helps the administrators manage the distribution of updates and hot fixes, at least for Microsoft products. And in the Linux world, there are other products that folks use. I'll list a few of them here. But application management, patch management, I should say, is critical. There are products that can help you identify vulnerabilities and help you really point out, even a medium-sized company is going to have hundreds of applications. It's hard to sort of keep track of what release you're on, and if there's a patch that you didn't know about or an update you didn't know about or a hotfix. There's a product called Nessus, Nessus, and it's here on the screen, obviously. And Nessus is a great product that scans your operating system, scans all your Windows machines, all the versions, all your applications that are commercial applications. If you created your own application, it's not necessarily going to know if you had to patch it. It knows the commercial products and what release they should be on. And it gives you a little dashboard of like yellow, orange, and red. Obviously, the reds are the most important vulnerabilities in terms of, the fact that they're probably very commonly known, and they're active in the wild. That's the term when they, in this security industry, they'll say this is in the wild, meaning it's out there in the world, heavily exploited. So those things will be red, and orange obviously less common, and the yellows are either weak vulnerabilities that don't create a lot of problems, or they're not commonly used. And you'll tackle doing your updates based on the orange, the red, orange, and yellow schema that Nessus provides. And on the bottom, I put down that Nessus you could run Nessus for free. You get 16 IPs for free that you could scan. So it's a way to sort of introduce people to the product, obviously. So it's kind of a nice product for people to know about. There's also this thing called zero-day exploits, the third bullet here. And unfortunately, these are attacks that are brand new. So if your environment, your system, your network is being attacked by a known virus, the antivirus, anti-malware, endpoint protections, they'll probably stop it. But a 0-day means it's new to the world. It's new in the wild. And there is no protection. There's no signature. There's no one knows about it. And it's always a risk. It requires emergency patching. And it may require and should require probably vendor assistance. So I've never experienced a 0-day exploit myself. I've lived through ransomware attacks. But 0 days are dangerous, and there's a lot of uncertainty. You and your vendor, your application vendor, your antivirus vendor, they haven't seen it before, and they have to figure out quickly, what to do with this. When you apply your patches, you have to test functionality and security. So you apply a patch for security reasons, it may break a function. So you kind of have to you can't just put patches in, but you have to test them. Patches can fix an issue and create other issues or break other things. So that's always a risk, but you have to test it as much as you can. A hot fix, you probably can't do too much testing till it's after it's in production, and do the testing in production, because the hot fix is implying there's a serious vulnerability that needs to be patched. You need to do it quickly, so you cannot spend a lot of time testing. Integrity measurement baselines. So software, you could take your software, particularly the software you've coded, if it's a large exposed application, you can hash the software. So we talked about cryptology already, and the hashing, you know what that is. It's adding up all the bits and bytes of the software, of the electronic version of it. The bits and bytes of it creates a sort of a fingerprint, a social security number, or more like a fingerprint for that software. So you have your code in production, you have a hash. You might want to, if something odd is happening, you could take the software, rehash it, and see if the hash matches what you have stored as your backup code, as your gold code, as your production software. If it doesn't match, and something happened to your software, it's either been corrupted somehow or it's been attacked, and you may need to redeploy it. So hashing is a good way to get a fingerprint on your software and compare that fingerprint to your standard, to what's called sort of your gold code, the backup version of your production live code. And then for mission critical systems, you could have various configuration baselines, because when you put a hot fix in or a patch, you may have some performance problems. It may slow the system down. It may cause some corruption to the way the data is input or changed in a database. So you should have some sort of baseline on your applications. There's some understanding of how how they work, what the latency is, what the delay is for certain functions, so that when you apply releases and patches and updates, you're not blind to knowing if there's a negative impact or not, because you have a baseline. You have a sense of how this application is supposed to work in terms of timings and things like that. Identify abnormalities and deviations from the norm caused internally or by external bad actors, right? So anything that's happening that looks different than your baseline is something that you need to pay attention to. Is there some abnormality that's happened because of your patch or your change? But you need the baseline or you wouldn't know. The other two products I listed here is Nmap. That's, again, it's free, and it does port scanning. It does, now this is software port scanning, right? It's looking for the logical ports that accommodate various programs, various services. Like there's a software port for email, there's a software port for file transfers. There are thousands of software ports. There are thousands of ports, and these are logical ports. They're not the physical ports that you see where you plug a wire in to the back of a switch or a router. Those are physical ports. These are virtual ports that are associated with services. So hackers look for a port that's open for file transfer, for email, for anything really, to see if they can gain access to your system. So that's a scanner. It's free. There's also a GUI version of Nmap called ZenMap, Z-E-N-M-A-P, you could download. And you shouldn't, for all of these tools here, like Nmap, and we'll talk about Wireshark in a second, you should not, it's illegal. It's illegal to use them against a party that has not given you permission. So you can't be running Nmap or Wireshark at your bank or at Starbucks unless or you could do your own home, do your own Wi-Fi or your own network and scan it. But it's illegal to do it against someone who's not aware that you're doing it without their permission. Wireshark is really a network sniffer. It's also free. It has the ability to sort of look at all the traffic going through your network. And it gives you the ability to, it's really what they call a sniffer. It's looking at everything. You can actually find passwords. You can, even if it's encrypted, you could steal that encrypted password and run it against what's called a rainbow table, which we'll talk about in the next module some more, to see if a hacker, these rainbow tables have billions of stolen encrypted passwords, and they try to match up whatever they could steal, an encrypted password, to see if they can find a match and then know what the password is. So this is all about application management, application coding, making sure it's safe, it's secured. You don't have vulnerabilities, and the tools on the bottom of things that people use to sort of ensure that Nmap, make sure there aren't ports that are open that shouldn't be open. That's the whole concept. Don't leave services open that you don't need to be open. Don't leave capabilities running that somebody could exploit. If you don't need it, shut it down. So Nmap can help you do that. Wireshark is a good way just to manage a network, right? You're not sniffing, you're not snooping on someone. That's what the hacker would do. You're managing and looking at your network when you have problems. And Nessus looks at all of your applications to see if the operating systems and applications have been patched, if they're patched up to date. So we talked about input fields, making sure that you can't be fuzzed. Input fields on your browser, on your applications, that hackers can't enter programs or scripts or damaging, inputs that can crash your server or exploit things with scripts. And we talked about keeping your systems patched, patch management, hardening your devices and your operating systems and your applications with the latest versions of all of the software, and how to scan with Nmap and Wireshark to kind of help monitor all that. So let's talk about some other hardening techniques that involve applications. So we mentioned earlier, remove or disable any unnecessary services, protocols, ports, any software you're not using, any capability, whether it's in the application. I mean, this goes, obviously just as much for your network, but since we're focusing on applications, anything that has to do with your software, shut down functions and features you're not using. Standard system images. So your endpoint devices, your laptops, your desktops, you should have a standard image, and that standard image should have only the software that you need for work for that function, and it should have obviously antivirus software. What's your endpoint security? So before you give a laptop to someone, a new laptop to an employee or a new desktop, you have to first load in all the proper software, take away things that you think might be vulnerable, keep it clean, minimize the applications as much as you can, and issue it with the latest antivirus. And of course, and that's with a standard images. There's also something called VDI. You may run into this virtual desktop image, which is really your desktop is now using all of the software it needs off of a server. And your desktop or your laptop just becomes sort of a smart way to connect. There's not much software running on it. So it does help with maintenance. It helps with keeping track of inventory licenses and updating the antivirus software if it's really residing sort of on this server. So it's called VDI, Virtual Desktop Image. I just thought of it as I'm looking at the standard image. Some companies use these VDIs for the remote users a lot of times, so they can just connect remotely, access a virtual desktop image. Their desktop is not really doing a lot of the processing. It's really done remotely, and they're really just viewing it. So like having a long wire from the server in the data center to the screen and your mouse and your keyboard, and all of the processing is happening remotely. Third bullet, keep antivirus software updated. Any endpoint malware protection you have, keep it updated. As far as hard drives, you could, or an SSD, a solid state drive, install encryption. You can turn on Windows BitLocker and make sure the drive is encrypted in case it's stolen or a laptop is stolen. At least the data is all encrypted with the password. And we talked about network protections. Here we're talking about host protections where the applications are running. But any host-based firewalls, intrusion detection systems, intrusion protection systems, they need to be updated. They need to be installed. Deploy them, install them, and keep them updated. Newer devices, desktops and laptops, have a different BIOS. The older BIOS that helps boot the system up doesn't have all the security that the new UEFI has. So if you have it, if you're buying new equipment, ensure that the boot drive is UEFI and not BIOS. Another big problem that folks have is UBS ports, because it's too easy to put data on there, and if it's lost or stolen, it's not encrypted, it's too easily misused. So you could either lock down the ports completely so that no one can use a USB and extract data, or you could minimally enforce BitLocker so that their Windows BitLocker, so the data is encrypted on the device, on the thumb drive, on the USB. So you either lock it down that it doesn't work at all. For certain people, you might be able to do it. For management, they'll probably say they need it for various functions, but either lock it down or minimally encrypt it. And that leads us to our next subject, data loss prevention, right? How do you keep data from leaving the organization? Data loss prevention, aka otherwise known as DLP. So there are technologies and strategies that you can use, and it's also important to have written policies and procedures, because data loss prevention is not something that you can rely exclusively on technology. Actually, probably no security concept can you rely just on technology, right? So, but it's important that people understand how to protect the data and how not to make it vulnerable. And there are companies that sell, technology for this. Semantic Forcepoint is big on this, Digital Guardian, etc., where you can buy products that help secure your data. So there are 4 risk categories for DLP, for data loss prevention. To the right, the dark blue is DLP for the network. Networks penetrated, obviously they could steal data primarily through FTP or spoofing your internet protocols, IP. So the network has to be protected. We have a whole chapter on that, a whole module just on network security. We talked about it, right? And storage, data loss protection for storage. How do you store them physically? How are they physically stored, secured? Is there encryption? How do you destroy drives that on machines that are being retired? You have machines with information on them, with data on them. How do you ensure that the data is not stolen when you throw out your drives? How do you dispose of these databases properly? How do you back them up properly? That's all part of storage. You know, the backups have to be secured. Backups can be stolen just the way databases can be stolen. Encryption is a very important piece of storage. DLP for the cloud. Obviously, most companies have a lot of data in the cloud, and you have to put some consideration there in terms of who's managing passwords, what the vendor's like that is providing the cloud services on it for you, and have a conversation, maybe even a written agreement about how data on the cloud is stored. If you end the contract with the cloud provider, ensure that the data is destroyed properly, that there's a written policy about how it's deleted or who owns the data. Sometimes there are calculations done on the cloud, and the vendor may say they own some piece of that data because they did some calculations that were beyond the scope of maybe even the original project, but they feel like they own this. So you have to consider that that as well. And then the endpoints, the sort of gold yellow here, DLP for the endpoints. Obviously, your endpoint antivirus, anti-malware, those kinds of considerations, removable storage. We'll talk about that some more, actually, in a little bit more detail, but how to protect it, or at least encode it, encrypt it so that it's not easily stolen and read. And then at the bottom of this slide, I have regular backups. There are full backups, incremental and differential backups. So a full backup is sort of like at the end of the month, you back the whole database up. Incremental is as every day goes by in the month, you're adding more to it. And differential is just that, say, day, or whatever the time period is. And each day is a separate backup, but they're incremental. So the differential, it only looks at changes, I should say. Changes from day to day. To restore those are more difficult because it's more complex to put the differences back together. The full backup is the easiest thing to restore. But there are different kinds of backups is the bottom line here, and just you have to use the different types judiciously and use them religiously and regularly so your data is backed up and you're not finding yourself without a backup because data was corrupted or some ransomware attack locked up or encrypted your data and you don't have access to it anymore. Protect removable media so that you don't have a data loss. Data loss prevention is what we have to focus on here. We already talked about USB policies. You can use Windows BitLocker to encrypt the data on the USB. So if a thumb drive is lost or stolen, the data is encrypted. Annual education is critical. It's very important that everyone in your organization understands the importance of security and understands the policies and procedures, understands the risks and regulatory penalties as well. Many industries have severe penalties for loss of data. Customer data or patient data that's lost, there are regulatory penalties for that. Encrypt sensitive emails. Most companies will have the ability to put a particular subject in, like a text, in the subject field of an email. Usually it's the word encrypt. If you put the word encrypt in the subject, it'll kick off a routine to encrypt the message, and it's handled a little bit differently by the recipient, who has to receive an email that says click here and log on to a secure email server to look and de-encrypt that and always encrypt file transfers. Most companies have many file transfers during the day, and weeks and months. There are hundreds of them. And an FTP is file transfer protocol, FTP, and there needs to be some sort of security. There's two different kinds of protocols, and one will display as FTP-S, and the other protocol, security protocol, will display as SFTP. There's some differences in how they work. Not it's too detailed for this course, but there's some advantages and disadvantages. But you need something. You need to encrypt. Obviously, you need to encrypt any file that goes out. So how does encryption happen? How does it happen to your machines, to your drives, to your when you have a function, an application that requires encryption? There are two things that on your machine that helps with this calculation, because it's a heavy mathematical calculation. One's called TPM, Trusted Perform Module. It's a chip on the motherboard that helps with encryption, that does the encryption. And if you need heavy encryption, very routine encryption, You might also install an HSM or hardware secure module, which is a card, to the right, the picture to the right. So the bottom line is there are special chips and modules that help you do this encryption because it would overtax your CPU and your normal in your processor. And then the other thing you should be aware of is that SQL databases have two different encryption methods built into them. And the TDE encrypts the whole database, and CLE can control a particular column in the database and not the whole database. So if you have a database that you're not too concerned about encrypting all of it, but there's a particular column that you need to encrypt, you can do that with CLE. Let's talk about server virtualization, typically done with a product at a company called VMware, very, very common product. This product is not a security product, but I'm just bringing it up to your attention because the way it works, virtual machines are created out of one machine. And the virtual machines, the VMs, could be different operating systems or the same operating system but different applications. And there's a hypervisor. And the hypervisor controls all the virtual machines. If the hypervisor is hacked, then the hacker has capability to enter any one of those machines, any one of those virtual machines. I have a couple of pictures here for those who are interested. It's not really germane to security necessarily, but there's a bare metal virtualization on the left and a hosted virtualization on the right. And the only difference is that the hosted has another operating system, that gold, yellow colored operating system between the hardware and the hypervisor. And I'm not sure one is more secure than the other necessarily, but it's just two different flavors of virtual machines, the way they're implemented. Let's talk about storage some more. Storage area network, SAN, and network attached storage, NAS. The NAS is less expensive, less secure, less sophisticated, and the SAN is a little bit different. If you look at the picture, it's a separate network for your storage. So it's not directly attached to the main network with all your other processes. Like on the NAS, you see the photograph on the NAS, the blue to the left. The drives, those little disks, are on the same network with everything else. The SAN segregates and gives you a little bit more security and control over your data because it's a separate network. More expensive, but better protection. A couple of things you should just be aware of. I put arrows on the more important things to look at. On the NAS, if you change one character in your file, the entire file has to be replaced. On a SAN, it's a lot smarter. It's block level data changes. So you change a character in a big Word document, only that one character gets changed. Of course, the SAN is more expensive, much more expensive than the NAS, as you can see from the second arrow going down. And the final arrow is the one that we want to focus on more. The independence in a separate LAN provides more security. And we'll see why on the next slide. Just having a separate network gives it more security, but there's another feature we're going to look at. So this other feature that the SAN provides is called LUN, a logical unit number. And essentially what you can do is logically control how data is spread across your drives and your systems. So it's just really a sort of a logical view. The drives are no longer appearing to the file servers as they exist physically. You can logically connect different drives together or pieces of drives into different LUNs. And the nice thing about that is the LUN can be associated with user permissions. So it gives you more control and another level of security in terms of managing your data by LUN and by user privilege type, your group of users. So the other security feature that a storage area network gives you is a LUN, a logical unit number. And what it does is it allows you to logically associate drives with create sort of logical drives out of them. The way you have virtual machines out of one physical machine, you could have different LUNs, different logical drives out of one, or you could have two drives that look like one LUN. So it's a logical drive essentially, as opposed to a physical drive. And the nice thing about it is this last bullet here is that each of these LUNs can be associated with user permissions. So certain users, certain groups of users can have access to certain LUNs and other users will not. So it gives you another layer of protection, another place where you can put some security and some segregating data by user and the way they have access to these LUNs, these logical drives. So The information security world and professionals worry not just about attackers, but about losing data and securing data, right? And there's this technique called a RAID drives, redundant array of independent disks. Sometimes people call it redundant array of inexpensive disks, because because of the way they protect each other, you don't have to have the most expensive, highest fail-tolerant disks. So let's look at these three different ways that disks can be hooked up. RAID 1 is a mirror. So if you look in RAID 1 on the left-hand column there is 4 blocks of data. It's mirrored an identical drive. So if one drive crashes, the other drive's up and running. It's expensive, it's safe, but it's very costly because you're doubling the cost of your drives. Because for every drive you need an alternative mirror. RAID 0 is a concept to speed things up. It's fast but not safe. And here's where we're going to introduce the concept of striping. So if you notice, block 1 is on one drive, block 2 is on the second drive, block 3 is on drive 1, block 4 is on drive 2. It's very fast because you can pull data out quickly because it's accessing sort of two funnels or two hoses of data, two streams of data instead of one stream of data. So it's very fast, but it's not safe. If you lose block 4, you lose block 4. You have to recover somehow with a backup of your data. RAID 5 is very commonly used. RAID 5 is safe, fast, and cost efficient. It's a little complicated to explain, but I think we can do this. So we'll start with 4 disks, right? 1, 2, 3, 4. If you want to make RAID 5 out of this, you add one more drive. And then you still stripe the data across. As you see, it's A1, A2, A3, A4, and then it says AP. That's a parity. That's a parity disk. It's going to have mathematics to be able to rebuild any drive that crashes by the data in the other drives and this math. So it says I lost a particular drive. Let's say I lose drive A1, it crashes. That stripe, A2, A3, and A4, has data in it. The parity disk there, the orange one, has all the logic and the math to rebuild automatically the data in A1 without you going to a backup. That's the beauty. It's almost like magic, right? It's taking the other data, but the way the data is striped in a way that there's some logic in terms of the striping that it can rebuild that lost data. So if you have 4 disks and you wanted to mirror them, you'd have to buy 8 disks. Pretty expensive, right? You went from 4 to 8 just to have protection, to have a duplication, redundancy. But by striping it this way and having this parity mathematical calculation, you're really only adding one more drive to accommodate those 5 pieces going across. Those little 5 orange slices going across from left to right. If you put them all together, it equates to one more drive. So you're adding one more drive to cover those 4 because you're losing some disk 1's losing the bottom one. Disk 2 is losing the one from the second from the bottom. Disk 3 is losing, I mean it can't use that middle disk in disk 3 for data because the parity mathematics is there. So you do lose the ability to store in those orange slices, but you add another 5th disk to accommodate for that, if you understand what I'm saying. So at RAID 5, the bottom line is it's safe, fast, cost effective, it's fault tolerant, and it's quick and it's cost effective. So it's what most people use today. Just a comment on system logs, reviews, and audits. So there's lots of data created from client servers, routers, firewalls. There's lots and lots of logs being created, security logs, event logs. It's difficult but they leave lots of information if you have a problem, if you think you were hacked, clues and traces. And they can also provide, alerts and trends and real-time monitoring and allow for forensic investigations if a crime, people think a crime has occurred. But how do you manage all of that? How does a human do this? You need an SIEM, a Security Information Event Manager, SIEM. Splunk, in the second paragraph here, is a very common tool that people use, that professionals use to pull the data together, pull all these and correlate the data. We'll look at a few others also in this class later on in the operations module. Other SIEMs that are out there, SIEM, IBM, and some others. But you need some way to correlate the data. You'll see, we'll go into more detail in another module about how they work. But all these kinds of logs for auditing, for managing, for real-time managing, retroactive looking at, are people, the most common thing that auditors look at when people leave an organization, or their accounts disabled. When they move around in a company, if they move to a different position, do they get the additional access to for the new position? But do they always lose access to all the systems they no longer need? So is that maintenance happening? When I was a CIO, Chief Information Officer, 4 times in my career, and once I was removed from having easy access to the data center because the auditor said, "You're the senior vice president. You don't need to walk into the data center anytime you want. How often are you in here?" So my access card was disabled for entering the data center. They said, "Well, you're going to go with somebody, right? They'll let you in and sign the log that you entered." But again, minimum privileges. You shouldn't have any privilege you don't need. I don't need that. As a CIO, you don't need access to the data center anytime you want. There's no need for that. I'm not a technician that's going to work on physical machines in there or load things or do network work. So all these log reviews and audits are important to ensuring that looking at failed attempts. There's some strange number of failed login attempts coming from somewhere. Is somebody trying to hack the system? Is it an employee? Does it look like it's coming from inside the organization, outside the organization? Are you getting an unusual number of ping attacks, to try to bring your system down? What's going on with your network? What's going on with your firewall? What's going on with your machines? And you do need some way to look at that. You have to look at it. You have to audit retrospectively. You have to look real-time monitoring, and it's work. It's very important. It's the only way to defend and to figure out what's happened if you do have a serious event. I'd like you to be aware of Qualys. Qualys is an interesting company, and they have this site called SSL Labs, and I have the site address on the top here. And they allow for a couple of, and I circled them with a yellow circle, they have a couple of online real-time tests. You can test the security of your server, test how secure and updated your browser is, and it's at no cost. Of course, they sell lots of other services and functions, but they put these 2 tests on the internet at no cost. You might have some fun with them, putting in some organization you work with or you know about, and test your own browser as well with that second tab there. So have fun with SSL Labs. I think you might find it enjoyable. You might find some surprises in there in terms of the security of companies that you work for or work with. So this module focused on ways to protect yourself. We didn't get into the different kinds of attacks, and this screen gives you a little bit of a list of some of the things we're going to focus on in the next module that covers malware and malicious attacks and things that hackers and bad actors do to get into your system. So fuzzing we talked about a little bit because that relates very much directly to obvious application input fields. But some of these other things, I'm not going to read and explain them here, but I just want to give you a sense of what's coming up in the next module, so you'll be more aware of how systems are attacked and what are the specific techniques.